When you're adding fractions with unlike denominators, the first thing that you need to do is you need to make sure that your denominators are the same so that you're adding the same size pieces. Some people right away see it, or they just multiply 3 times 6. The most efficient way is to find the least common multiple. So if you're not seeing right away what the least common multiple of 3 and 6 are, you can list them on the side, and you'll really quickly see that the least common multiple of 3 and 6 is 6. So now I can go ahead and change my numbers so that the fractions are the same. Now 5 6 doesn't need to change because the denominator is already 6, but I need to make 2/3 into 6, so I'm going to do times 2. Whatever I do to the denominator, I need to do to the numerator times 2. And that's going to give me a new fraction of 4 6. Now my fractions are able to be added together because they have the same denominator. So I get 9 6. And then 2 wholes. But right away I notice that 9 6 is more than 1 whole because 6 6 equals 1 whole. So really that means that 9 6 would be 1 whole and then 3 6 left over. So I'm going to add that back on to my original 2 to get an answer of 3 and 3 6, which is also equivalent to 3 1/2 because 3 6 is 1/2. You also need to have a common denominator when you're working with subtraction. So again, I always like to stack my numbers so I can clearly see them. Again, you'll notice I don't have the same denominator, so I would have either had to find my least common multiple in my head or by listing them on the paper. And right away I see that it's 20ths. So I'm going to do times 4, so that this new fraction becomes 3 and 4/20. And then on bottom, I'd have to multiply the top and bottom by 5, so it'd be minus 1 and 15/20. Now I see a whole new problem, that I can't say 4 minus 15, so I need to regroup. So I'm going to go to the 3 wholes, just like for when we regroup with whole number subtraction, and that 3 is going to become a 2. Now if I borrow 1 whole here, I really want to borrow it as a fraction. My denominator is 20, so I know that 1 whole should give me 20/20. So really altogether now I have 20/20 and 4/20. So now it's really like saying I have 2 and 24/20. Now I'm able to subtract. 24 minus 15 would give me my 9/20, and 2 minus 1 would give me my 1. Now many of you last year were solving these by making them into improper fractions or fractions greater than 1. And to do that, you would say, I know for this number right here that 1 is equal to 5/5 because my denominator is 5. So you do 3 times 5 is 15 plus 1 is 16/5 minus, and then again here, 1 whole would be 4/4, so 4/4 plus 3/4 would give me 7/4, and then you'd find your common denominator and subtract. Both are great strategies to use. When we multiplied last year, we thought of multiplication using the word of. So really we're taking 3/4 of 2/3. A lot of times we talked about land sections. So we have 2/3 here, but now I only want 3/4 of the 2/3. So I'm going to break it into 4 equal pieces. And then I'm just going to color in 3 of those 4 pieces because I only want 3/4 of the 2/3. So if you look at my visual, you can see I have 6, and out of the entire land section of 12. So my answer would be 6/12. We also started to notice that we can multiply across. 3 times 2 is 6, and 4 times 3 is 12. So your answer is 6/12, which is equivalent to 1/2. Using that same strategy, we can look down here at 2 2/3 times 1/6. Again, a lot of us were using where we change this 2 2/3 to be an improper fraction or fraction greater than 1. If we know that 1 equals 3 over 3, then 2 would really be 6 over 3 because it's 3 over 3 plus 3 over 3. So I'm thinking 3 times 2 is 6 plus the other 2, 7, 8. That's 8/3. Times my 1/6. And now I can multiply across. 8 times 1 is 8, and 6 times 3 is 18. And if you're thinking about equivalent fractions, I know I could break both of those in half, so that would also be equal to 4/9. When you have 5 divided by 1/4, I'm thinking of starting with 5 wholes. And so when I picture a whole, I know I need to see how many fourths can fit into one whole. So I would take my whole and break it into 4 equal pieces. So when I draw my visual, I would have 5 wholes broken into 4 pieces. Now I want to know how many 1/4ths fit into 5. Well, in each of these, I got 1, 2, 3, 4. So that means 4, 8, 12, 16, 20. 20 1/4ths fit into 5. So my answer for 5 divided by 1/4 is 20. It's a little different when you do 1/4 divided by 5. I started with my 1/4, and then I split it into 5. Think about 1/4 of a piece of a cake left, and you want to share it with 5 friends. How much of the entire cake would one friend get? Well, they would get 1 piece out of 20 of the original cake. So since you're starting with 1/4, your answer is smaller because you're splitting that into 5 pieces. The same thing works when we think of 5 divided by 3/4. I want to say how many 3/4 fit into 5. I find it best here to use 2 different colors if you have them. So I'm going to make one group of 3/4. So that means one group of 3/4 fit in. 2 groups of 3/4 fit in. 3 groups fit in. There's another group of 3/4. Another group of 3/4. Another group of 3/4, and then there's 2 pieces left over. So when I look at it, I can say I have 1, 2, 3, 4, 5, 6, and then this piece would represent 2/4. So my answer would be 6 and 2/4 for how many groups of 3/4 can fit into 5. It would look very similar when I think about 3/4 divided by 5. Think again about that piece of cake. I have 3/4 and I want to split it into 5 equal pieces. So I go 1, 2, 3, 4, 5. And so I'm asking how much would one of those pieces be? So that one of those pieces would be 3 out of the entire piece of cake, which would be 20. So it'd be 3/20.